Hello and welcome. My name is Sarella, and I am part of the program committee, and it's my honor to introduce our next speaker. Our next speaker, Garen Torikian. Garen has been a Ruby programmer for close to 20 years, and it's still his favorite language to think in. He maintains the Common Maker gem, as well as way too many other open source projects. In his day job, he is a CTO at Yero, a messaging platform for support teams. In his spare time, he writes fiction and nonfiction. Please join me and give him a warm RubyConf welcome, Garen Torikian.
Hello, hi, everybody. Thank you all for being here. Thank you all for watching the stream live, and a special hello to anybody watching this video in the future. I hope your world is better than the one we are in right now. This is my first conference talk in a long time, my first RubyConf presentation, so I apologize if I'm a little rusty. Today I'm going to talk to you about Rust and Ruby. As Zarela said, I'm the CTO at Yero. I'm at GJ Torikian almost everywhere on the web. CTO in this context is a pretty meaningless title. There's only 3 of us. And basically the only reason I'm CTO is because I happen to be best programmer. But that's also a meaningless title because that just means I'm worst salesperson at Yero. But for the purposes of this talk, you can just think of me as Chief Translation Officer. I want you to enter this talk with a mindset of translation, communicating from one language into another. And so Yero is a customer support tool built from the ground up to connect data, systems, and people. Messages can come into a support inbox as email, and support agents can forward that conversation to GitHub or Linear or Slack or any of the other platforms we're connected to. The character in the middle is Billy the Yeti, our mascot. And so, as you can imagine, Yero makes a ton of API calls to facilitate these integrations, right? But we also do a lot of text manipulation. We need to be able to convert between GitHub Markdown and Linear Markdown and whatever Slack uses into HTML so that it can be sent back out as an email to the customer. So that no matter the source of the message, we deliver it through Yero to another platform. So let's start with a story. Around 2015, the Common Mark project took off. If you're not familiar with Common Mark, it's basically Markdown with a spec. If you've never written Markdown before 2015, I'm going to tell you it was a wild time. You could not trust any text input anywhere because you didn't know how it was going to render. So a bunch of people got together, they made a specification so that, no matter what programming language or where you were on the web, you could just write, Markdown as you expect it. And for me, I was motivated to write the Common Marker gem in part because there weren't any other Common Marker gems at the time. Except as I tried to write the gem in a way that matched the spec, every time I benchmarked my code, I found it to be pretty slow. And when I submitted this talk, I stated a very controversial opinion in the abstract. But like a lot of opinions, this one was meant to elicit a response, right? I wanted half the people in this room to, start clapping and applauding. Finally, somebody's saying the quiet part out loud. But then I wanted the other half of the room to kind of sit back and cross their arms and expect me to justify this statement. And I know this is the part of the talk where I'm supposed to show charts and numbers and benchmarks showing, backing this statement up. But I'm not going to do that because that's not what this talk is about. Instead, I'm going to give you a tautology. There are many people working on Ruby's runtime. Ipso facto, the language is slow. But no, seriously, people with literal PhDs are working to improve Ruby performance. We are looking forward to YJIT landing. We've heard from Prism parsing this week. There's JRuby on the JVM. There's Truffle Ruby. There's Artichoke. There's all these different ways that people are trying to make Ruby faster, and I'm incredibly grateful to all of them. And in fact, we should all be incredibly grateful to all of them. But still, benchmarks show the language is slow compared relatively to a compiled language. So knowing all that, what did I do to make Common Marker fast? Simple. I just use C, which is a compiled language. The team behind the Common Mark spec have a C library that they call libcmark. And this library takes in Common Mark text, It creates an AST representation, and then it spits out HTML. And so here's what that looks like in the context of a Ruby gem. A Ruby user passes a string into the gem that goes into some underlying glue code. That glue code takes that string, it converts it from Ruby into like a C format string. That C string goes into libcmark. Libcmark does whatever it needs to do. Libcmark sends the result back to the glue code. The glue code converts that data back into Ruby data. So all a Ruby user has to do is install the gem, and they get all this performant magic for free. We've taken all of that heavy lifting out of Ruby and put it into C. And here's some example of what that glue code actually looks like in practice. These are all very real from the actual gem itself. So first, we define a function in C that converts between these Ruby and C data types, right? Ruby has no types. Doesn't sound like it's likely to get types anytime in the near future, which is fine. So to represent anything in Ruby, the C API uses something called value, right? And value is anything, digits, numbers, whatever. Those are both the same word, digits, strings, you know what I mean. And since value can be anything in your C code, you need to check that it's a string. And if it is a string, then you need to convert it into a C string. And now that we have a C string, we can start working with libcmark. We take that string, we've converted it, we give it to the library, and the library does its thing, and it spits out HTML. And now our glue code, has to prepare that string to send back to Ruby. You shouldn't forget any memory you've allocated to clear it. You have to close any doors you've opened along the way. And that glue code just sends that, that data back out to Ruby. I don't remember who said this. It really sounds like something I heard Tenderlove say when we were at GitHub. Is this sentence accurate? Probably not. Is it funny? I think so. And so one of Ruby's strengths is that it's so tightly coupled to C. It's really, really easy to write C-backed Ruby gems. Even when you're writing some of that Ruby code, some of that C code, it feels kind of like Ruby-esque, right? So maybe another way to stay that original controversial opinion is that Ruby alone is slow. I think that's a subjective statement that we can all agree on. Whenever Rubyists need to do something that requires time-sensitive, performant work, we dip into C. Who's doing this? Who else is using C? Nokogiri uses C for its HTML parsing. PG and MySQL use it for database connections. Liquid template parsing, PsycYAML parsing, OJ and JSON, Bcrypt, Puma, gRPC, all these message serializers, all of this is C code, there's C code running when you think you're running your Ruby code, right? And so when you're writing these C extensions, there's so many examples and so many tutorials that tell you how great it is to be able to access the power of C. All you have to do is write this glue code, right? You just take data in, convert it, spit data out. Fun, awesome. And it is great, right? I've written C code for Java, I've written C code for Node, and neither come close to how easy it is to do in Ruby. Except you are not just in charge of your C glue code, right? libcmark is not maintained by me. I don't review the PRs that go into that project. I don't keep up with its security implications unless somebody tells me I'm doing something else with my life, right? And now I just want to be super clear, I don't hate C. I've been writing C since I was 15. I think everyone should know C. I think it's a great educational tool to understand how memory works, right? And so even though Rubyists agree that sometimes Ruby needs a speed boost from C, why shouldn't we keep using it? If I'm going to go as far as saying Ruby is a DSL for C, it seems natural to keep using C whenever necessary. As a counter-argument to that, take a look at this graphic. This is a cross-section of a brain. It's obviously not to scale. Mine is much, much smaller. But this is a normal, healthy, brain. And this is this is the cross-section of a brain of someone who's worked with computers for way too long. I realize this is a subjective slide, but please just follow me on this. people might tell you all sorts of things about how it's not that hard to write C. For me, it's not a matter of not knowing C, it's a matter of not wanting to know it. I have forgotten more glyphs, more syntaxes, more gotchas than I care to remember. But if I forget a quirk in a language or I make a typo, it doesn't result in a catastrophic error necessarily, right? If I make a mistake in C, at best, my program is corrupted, and at worst, I've introduced a security hole. So again, I understand how memory works, I know how to manage it, but I don't want the software I write to be held captive by that requirement. But don't take my word for it. Like, here's a bunch of quotes from some actual CTOs saying the same thing, right? I almost didn't include this slide because I was worried that it made me look like a Rust fanatic. I am a Rust fanatic, but I didn't want to look like one, right? So if you know nothing about C or what memory safety in C means, that's fine. But like, consider that people who work in that language are terrified by its security issues. Consider the fact that the peers in our industry are, moving away from C. Granted, consider the fact that all of these quotes come from corporations and you shouldn't trust anything they say, but that's on your own prerogative. But the quote that's of any real import is that one in the bottom left. A little over a month ago, there was a security vulnerability in curl, and its developer said that part of the problem stemmed from an issue that would have been mitigated if curl were written in a memory-safe language like Rust. So if even a professional C developer is making a mistake, what hope do I have of not making one? I'm just a humble Rubyist, right? So moving on, let's stop talking about C. Let's talk about what happens when you try to marry Ruby and C. Here's another familiar site for people running and installing C extensions. When a C extension crashes at best, you get a backtrace like this. And when a dump like this happens, you'll see a bunch of files and line numbers that represent the stack trace, right? But this doesn't necessarily show you where a problem occurred, right? It's only where a problem was encountered. You could have mishandled your memory in one function and only much, much later hit an issue. And debugging memory issues can be hard. They can be very, very frustrating and very, very difficult. C tooling exists like GDB and Valgrind and Address Sanitizer, but those can be difficult to set up and install, right? And speaking of difficult to set up, each platform you want your Ruby gem to support needs to take into consideration the CPU and the operating system of the end user, right? So now your Ruby C extension developer needs to be aware of writing C code for all sorts of OS and CPU idiosyncrasies. OS updates can be moving targets, and although you can write all the if-else statements you want, as a C developer, you really, really, really hope you've got those escape hatches correctly. So if you've ever lightly dabbled in Ruby C extensions, you're maybe familiar with the first two dragons, right? You're working in C, you're trying to concatenate a string, you're trying to expand an array, all of these things deal with memory management. And a lot of the tooling, I'll say, for C is written from the era that C came from. It's all very 70s, command line heavy, and the tooling still behaves as if we're kind of in that era. So while these first two dragons are specifically C issues, they're language issues, it's the last one that I think is often ignored in a lot of tutorials, and to me, it's the most irritating one. So has this ever happened to you? You install a gem, it tells you it's building a native extension, it could take a while, and then it crashes. So what happens here? It's okay, so your computer has just downloaded a bunch of Ruby code and a bunch of C code from Ruby gems. And for C-backed extensions, the person installing the gem needs to also be able to compile that C code. So even though my machine compiled C and pushed it to Ruby gems and everything was fine, I need to make sure that your machine can also compile C and run that same code. Admittedly, in a lot of cases, this isn't a huge problem. We're developers, we've installed all sorts of tool chains and dependencies that we've forgotten about on our laptops. But still, it's a very real, legitimate, frustrating issue if you haven't, users can configure their machines in ways that you perhaps haven't anticipated. And so wouldn't it be great if we could just do away with memory issues by using a memory-safe language like Rust? Wouldn't it be nice to write highly performant code in a language from this century, not the last one? Actually, yes, it would be great. That's what the rest of the talk is going to be about. I belong to a community on GitHub called oxidize-rb. It's a collection of Rust and Ruby enthusiasts. There are dozens of us. We have a fairly active Slack. You can join or lurk, ask questions. We're all super friendly. And my real hope with this talk is to show you all how truly simple it is to integrate Rust into Ruby. I don't say that lightly. People have been trying to put Rust in Ruby since at least 2015. A lot of projects have been started. A lot of projects have been abandoned. But in the last few years, it's gotten like crazy feasible. I also want to say, these are the things I'm not going to talk about. Technically, you don't need to use C or even Rust as your glue code, right? If you want to tap into any faster native language, you can do so, you know? But I'm not going to cover any of those other ones. Documentation, both the Rust community and the Ruby community value up-to-date, good-looking documentation, and you can actually create static sites that combine comments from both languages into one coherent page. And then I'm also not going to talk about concurrency, stuff like Rust's Tokyo or async Ruby. I'll get into why a little bit later, but if you're looking forward to that, just keep your hopes tempered. Okay, so I'm going to show you all how easy it is to write Rust in Ruby, right? And so I'm going to come up with a project idea. I want to take a string, and I want to convert each case in that string to an alternating case, right? If you haven't realized already, I'm perpetually online, so this way I can make all the SpongeBob memes I can make as quickly as possible. So first stop, find a Rust crate that does what I want it to do. Found this one, it took 35 seconds. It sounds like it works, so I'm going to use it. So to start our project, I'll call bundler gem with the name of my gem, except instead of stopping there, I'll also add --ext equals Rust. And that indicates to bundler I want to create a Rust-backed gem. This has been around in bundler since early January 2023. And it creates all the files and the folder structure, everything you need to do to get Rust in your Ruby. This is literally like 65% of the way there. So if you were expecting a slow burn, like, no, we're ready. Bundler creates this toml file for us. Toml is what Rust uses kind of to manage their dependencies, kind of like how we have gem files in Ruby. And so since all of this toml was already generated for me, I only need to add my new Rust crate as a dependency down at the bottom. We'll switch back over to Ruby for a quick sec. This is what I want the API of my gem to look like. I want a class, I want to give that class a string, and I want to be able to call a method called alternate case, which alternates the case. And then I'll also, bundler creates this sort of skeleton file for you. I want to create an initialize method there, and I also want to define that alternate case method, which behind the scenes is going to call a function we haven't seen called toAltCase. And that's going to call the underlying glue code in the Rust library, in the Rust glue. So with that foundation in place, we're ready to write some glue code, right? And to do this, we're going to rely on something called Magnus. Bundler brought in Magnus for us. It's an as official as it gets in an open source project. It's officially supported by Bundler. I guess you can describe it as a framework. That's not really super accurate, but basically it does a lot of the Rust in Ruby binding magic for you. It's kind of hard to explain without examples, so we'll just dive in. Don't commit this to memory. I just want to show that this is the entirety of what the Rust code that needs to be written. And so we'll start at the bottom, right? We see this Magnus init declaration. It defines this method as an entry point for the glue, sort of like a main function in other languages. If you've written a C extension before, this should look very familiar. Magnus kind of just copied the same C API naming structure. And in this init method, we're going to expose two methods. One is a singleton called new, and the other is an instance method called toAltCase. And the only other thing of import here is that the integer at the end just indicates the number of arguments that the method is expected to take. At the top, we import our crates for Magnus and our gem change case. And we also define in Rust what we want our Ruby change case class to look like, right? In Rust, they're structs. In Ruby, they're classes. And again, Magnus wrap is a hint to our build system that this struct should be associated with that Ruby change case class. And this struct, like our Ruby code, only has one field, str, which is a string. So now we'll just implement the two methods that we previously defined. Initialize creates that struct. Behind the scenes, Magnus takes that Ruby string and it converts it into, it lays it out in a rusty kind of way. And similarly, toAltCase simply takes that Ruby string, Magnus converts it, and it sends it back to that Rust library that we looked at earlier. The Rust library returns, its string in Rust format. Magnus converts that into a Ruby string, and we send that back to the user. So all that work, we just did that in one line of Rust, right? So here's a side-by-side view of what writing this gem in Rust might look like versus what it might look like in C. As we saw with Common Marker, a lot of the C code is dedicated to converting between Ruby and C types. There's a lot of type checking. We have to explicitly set an IVAR. There's just a lot more verbosity, right? And in this case, we don't need to free any memory because we didn't do anything around that, but that's still an underlying concern in many C cases. If you work in VS Code, great things happen if you start using Magnus. You get instant documentation, right? You can look at examples. You can navigate around symbols. None of that exists for C, as far as I'm aware. And if it does exist, then I haven't spent the time to set my editor up. My point is, it's extremely easy to just get started diving in. Real quick, automatic Magnus conversion between Rust and Ruby works for a lot of things, not just strings or numbers. At the top of this, you can do options, which are kind of like nillable args. Vectors are just flattened out into arrays. At the bottom, showing that you can actually call out two Ruby functions, which can be useful for fetching consts or configurations that you just prefer to keep in Ruby. And you can also raise Ruby errors in a very rusty way. In this case, we will raise a type error in case, we receive something we didn't expect. And so by using Rust, we've defeated that first dragon, right, of memory safety. And we can move on to the second. And for that, we'll take a look at another VS Code extension called code LLDB. And as its name implies, it integrates VS Code with LLDB. So in practice, that looks like this. You can create a debugging environment in about 5 lines of JSON. You can use the VS Code UI to run a test or a sample script. When the debugger stops, we can inspect any of our dependent libraries types. We can look at what's sitting in memory. Total time to set all of this up, 30 seconds, right? So just super, super quick, super easy. And once more, we arrive at that final dragon, right? Even though your local machine might have Rust, even though you're able to build and compile your project and you can make that gem, how do you make sure somebody else who's installing it can use it? We don't want our Ruby users to have to install Rust or any tool chains to build and use our gem. So pop quiz. How do you build for platforms you don't have access to? Please feel free to shout out if you know. Close enough. It's the magic of Docker, right? You know it, you love it, it's so amazing. So I showed a variation of this screen earlier, about 10 minutes ago, as an example of distribution errors, right? And while this error is 100% legitimate, it still occurs for a lot of C-based packages. For Nokogiri, at least, the problem has been solved. Mike, aka Flavor Jones, aka one of the maintainers of Nokogiri, gave this amazing talk on distributing C gems from a few years back. He explained the distribution problems really, really well, and he discussed an improvement in the release pipeline, which Nokogiri made. So rather than expecting the user to perform the necessary compilation, he decided to pre-compile Nokogiri using Docker containers and then upload those to RubyGems. So each Docker container, or sorry, each Docker image represents an operating system or CPU architecture pair which he wanted to target. So this way, a user can download a pre-compiled gem for their specific platform without doing any of the compilation work for themselves. We let the computers in the cloud churn and churn and churn, and the end user just downloads the final result, right? Computer in the cloud is running Linux x86, you're running Linux x86, you've got your gem for you, voila. And so building on these concepts, we can do the same thing for Rust in Ruby. Here I've configured just some GitHub actions to build versions of my gem for each platform. And when Rust finishes compiling, when that process finishes compiling, it's just released to RubyGems automatically. And RubyGems will, segment each CPU OS architecture pair as a separate installer. It's actually a pretty cool feature. Again, I don't know why a whole lot of C gems aren't using this, but it's something to consider. Oops. And so technically speaking, right, all of that pre-compilation work can be done with C extensions. What I haven't seen for C is something like this, a full suite of CI actions that are generalizable and not scoped to one Ruby C extension project. This is some of the work that Ian and others are doing in the oxidize-rb group. A lot of that fundamental Rust language glue work is done, but there are always places where the DX can kind of be standardized and improved upon. And just to bring it back to the very, very beginning, this is more or less what a Rust-backed Ruby gem that converts common mark now looks like. A lot of the language integration works because the Rust, the Magnus, the deployment integrations were all built on top of existing C avenues for integration. So again, a lot of people spent a lot of time getting C extensions working for Ruby. Rust just came in and can build on top of those principles just as easily. And no matter what language you care about, no matter what language you prefer to write in, I personally think like the code on the left cannot match the simplicity of the Rust on the right. The only thing missing from this code snippet is accepting options and hashes and just kind of like toggling options in the underlying Rust common mark converting library. I don't have to think about, if somebody didn't give me a string, Magnus will raise that for me. If I have to grow or shrink something, I can do that in a very Rusty way and make sure that I haven't introduced any security issues. But of course, it is not always all smiles and sunshine. Environmental differences can and do occur with Rust. Particularly around CPU architectures, 32-bit, 64-bit, Intel ARM Mussel. But still, I think that in Rust, these issues are much, much more manageable. As well, the onus of fixing those architecture issues are kind of on the Rust core team, not the C library and not the Ruby extension author. I will say the biggest gotcha with the Rust bindings is knowing what data is stored where. This has to do with working around Ruby's garbage collection. If you've written enough Rust code, you kind of understand sort of, the compiler will basically yell at you if you're doing something even slightly incorrectly. So yes, like while you still have to know how memory works, I promise you it's much, much easier. You already should want to know how memory works even when you're writing your Ruby code, just in terms of data structures and how things are being allocated. And that's exactly what you do in Rust. You just think about where, versus whether stuff is being allocated on the heap or the stack, like just being aware of how things work is enough to get you past Ruby's garbage collector. And then the final gotcha, I guess, is that Magnus's API is stable, but there are still a few missing items. That's basically anything dealing with async, fibers, ractors. There's ongoing work to implement these, but there's, it's just a small open source project, so there's not a whole lot of people working on it. If you're interested in helping, there are opportunities around this stuff. And so yeah, I really, my goal again, I really hope this convinced you to take another look at dropping C extensions. Maybe go into your code base and take a look and see how much C you're actually running. Here are a few links for some of the things I mentioned earlier. That's the landing page for the oxidize-rb group. There's a QR code for yeto.app if you want to learn more. And then I've also uploaded the entire demo app that we went through for the change case RB project. That includes the GitHub actions and just everything you need to get started doing this stuff. Thanks very much.